Okay, in this video, we are talking about how we expand a binomial. That is a two-term expression raised to some random power, right? Which is a numerical power, a whole number, not like a half or anything, but a whole number power. Okay, we're going to do it with a four-step process, okay, where step number one is using the correct term from Pascal's triangle. And if you're not familiar with Pascal's triangle, let's take a moment and help you create a Pascal's triangle. So Pascal's triangle is what you get are the leading coefficients of each term in a binomial expansion. So let's do some actual, and then we'll look at the pattern, and then we'll just use the pattern from now on. Okay, so if I had a plus b raised to the 0 power, hopefully you know that anything, no matter how big it is, raised to the 0 power is always 1. Okay, so a plus b to the 0 power is 1. Now, what if I had a plus b raised to the first power? Okay, then the coefficients of my a and b are 1 and 1. There are two coefficients because I have two terms. Okay, now what if I raise that same binomial to a second power? Okay, so if you remember, a plus b squared means multiply it by itself. So I have one a squared term, and I have one b squared term, but what about in the middle? Okay, I have an AB here, and I have another AB. So how many ABs do I have? I have two of them. So the coefficients of a squared are 1, 2, and 1. Okay, now I'm not going to do this, but if we were to do that same multiplication out with a third binomial multiplication in there, we would get a 1 and a 3 and a 3 as the coefficients, and finally a 1. Okay, and with this pattern, we can generate everything else. So notice that your first terms are always 1, and the middle terms are found by adding your two previous above it. So 1 plus 2 is 3, 2 plus 1 is 3. Okay? So we can use this pattern to make more and more rows without having to multiply everything out. Remember, these are only the coefficients. So my first term is always a 1. And then 1 plus 3 is 4. And 3 plus 3 is 6. And 3 plus 1 is 4. And then, of course, it always ends with a 1. Okay? So we can continue on this pattern filling out every single coefficient. Remember, these are just coefficients. So if I were going to do a plus b to the 5th power, okay, that is a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then we always end with a 1. Now remember, these are just the coefficients of your terms, right? These are not the actual terms themselves, but just the coefficients. Okay? And then the amazing thing is, watch what happens to our values. So this is going to be A, and this is going to be B. Yes? And then I have an A squared, and then I have an AB, and then I end with B squared. Okay, and then I start with a cubed, and then I have a squared times b, and then I would have a times b squared, and then I would have b cubed, right? These are now the powers of each of these terms. Okay, so hopefully you're noticing there's a pattern here. Your first term is to the 3rd power, and then the 2nd, and then the 1st, and then the 0. So your first terms are always decreasing in powers from left to right along with your terms. And your second ones are increasing in power. So b to the first, b to the second, b to the third. Okay? So this is how we're going to generate all of our terms. If it's the fourth power, then it starts with 4. And our first thing counts down from the highest to 0. And of course, we don't put 0 down there. And our second term counts up from 0 to 1 to 2 to 3 and then to 4. Okay, so knowing this pattern is going to help us come over here with our binomial expansion of our actual algebraic stuff. Okay, not only is it crazy, it's amazing. Let's apply this to a couple of actual problems. So let's look at expanding x plus 2 to the fourth power. X plus 2 to the fourth power. Okay, so we're going to use some steps. Our first step is write down your Pascal's triangle. Oh, I've already got that. Pascal's triangle, that's what we want to do first. So it's a fourth degree, right? It's a fourth degree. So I have a 1 plus a 4 plus a 6. Let me go back over here and look. 1, 4, 6, 4, 1. Okay, good. There we go. 1, 4, 6, 4, 1. And we're always adding these things together. They're plussed. We are plussing their terms. 1, 4, 6, 4, 1. Okay, so the next thing we do is we deal with the A stuff. A descending, right? Our A values descend. Descending in powers. Okay, so this is my A term. My x in this case is my A term. So this is x to the fourth, and then x to the third, and then x to the squared, and then x to the first, and finally x to the 0. But of course, x to the 0 is just 1, so that's not really going to contribute anything to my fifth term there. Okay, so our next step is we deal with our b's. We do our b stuff, and our b's have ascending, right? Ascending powers for your b stuff. So this would be, this one is b to the 0, so we don't have to write a b there. Oh, by the way, bt dub, your b value in this case is 2. So this is times 2 to the first, and times 2 squared, and times 2 to the third power, and then finally times 2 to the fourth. Okay, so you start with your coefficients from Pascal's triangle. And then you do your A, your first term of your binomials, right? They have the powers that descend, and then you do your B's, which are the powers that ascend. They go from 0 up to the total. Okay, so now let's do some simplifying if we can. Okay, nothing to simplify here, so your answer is just x to the fourth. Okay, in the second term, I can multiply 4 times 2. So 4 times 2 is 8, x to the third. In our third step, I can do 6 times 2 squared, which is 4. So 6 times 4 is 24, x squareds. Okay, and then the fourth term, I have 4 times 2 cubed. Now 2 cubed is 8, right? 2 times 2 times 2 is 8. So 4 times 8 is 32. X is there. And then my last term is 2 to the fourth. 2 to the fourth is 16. So this would be your expansion of x plus 2 raised to the fourth power. Okay, x plus 2 raised to the fourth power. Okay, now this is the simple, most direct way that I have found to teach how to do this, right? There are lots of other methods, and there are including the combinations, right? Each of your coefficients of your Pascal's triangle can come from a combination, but if you don't know the formula for the combination, that doesn't really help you. Where Pascal's triangle is pretty easy to make. So let's look at a little bit more complicated problem. So we're going to expand 3t minus 2v raised to the fourth power. Okay, so once again we have a fourth degree, so we're going to use Pascal's triangle coefficients from the fourth row. I guess it's really the fifth row since the first row is 0. So those were 1 and 4 and 6 and 4 and 1. Okay, so your first step is to write down your coefficients from Pascal's triangle. Okay, and the second step is to do your a values in an ascending manner, right? I mean descending. So we're going to start with the fourth power, and we're going to go to the third, the second, and the first, and then to the 0. So we have 3t to the fourth. And remember, this is always multiplication. So times 3t to the third times 3t squared. There, the square goes on the outside. And then times 3t. And then we don't have to multiply our 1 by anything because 3t to the 0 is just 1. So we leave that one blank. So now we're going to expand our b values. Now the b value includes the -2. Okay, so we take the whole entire thing with us when we're doing our b expansion. So there's nothing here, right, because this is to the 0 power. So we don't include anything in the first term. So our second term is multiplied by -2v. And then we multiply by -2v squared. And then -2v to the third power. I should have given myself some more room in there. And then our last one is -2v to the fourth power. Okay, so we are multiplying my -2v to different powers. So let's do some simplifying. Okay, so I can raise this one, right? 3t to the fourth. I can raise 3 to the fourth power and t to the fourth power. So 3 to the fourth is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So our first term is 81t to the fourth. Okay, and then plus 4 times 3t is 3 times 3 times 3. That's 27 t to the third power. And I'm going to eventually multiply that by -2v also. So I'm just doing some simplifying before I do my expansion. Let's see, 6 is our next term. And then 3t squared is times 9t to the second. And what about -2v squared? So that's -2 times -2, which is +4 times v squared. Okay, plus 4, our next coefficient, times 3t, right? Nothing's going on there. But then we have -2v to the third power. So -2 times -2 times -2 is -8. V cubed plus, and then my last one is -2v to the fourth. -2 times -2 is +4. So this is a 16v to the fourth power. Okay, sometimes it helps if you do a secondary multiplication step before we do our final simplifying. Okay, so if you're good with your brain, that's awesome. You might need to get a calculator if you want some help. So nothing changes here, so this is still 81t to the fourth. That's your first term. Okay, your second term is 4 times 27 times -2. So this plus here is going to become a minus because it's going to be a negative term. So 4 times 2 is 8. 8 times 27 is 216. And I have a t cubed as a variable and a v. So our second term is minus 216 t cubed v. Okay, plus 6 times 9 is 54. 54 times 4 is, that's 216. And I have a t squared and a v squared as my variables. So my third term is 216 t squared v squared. Okay, and then the next one is going to be a minus because I have 4 times 3, which is 12, times negative 8. So minus 96 TV cubed. And then nothing changes with my last one, so that's just 16V to the 4th. Okay, so these are all 5 terms of your 4th power binomial expansion. Okay, so we start with Pascal's triangles coefficients. And then you go to your A thing, right? Your A value, your first term of your binomial, and you raise it to the 4th power, and then the 3rd power, and the 2nd power, and the 1st power. So every term gets decreasing every single time, right? Successively smaller. And then we come back with your B value, and you have no B value in the first term, but then B to the 1st, B to the 2nd, B to the 3rd, and B to the 4th. Okay, we do as much simplifying in our brain as we can until we finally multiply everything out to give us our total binomial expansion using Pascal's triangle and the binomial theorem.